Last problem on the learning guide. Okay. An offshore oil well is 3 kilometers off the coast. So let's draw it. Here's our oil well. Boom. Oil well. It's off the coast, so let's say here's our coast. And it's 3 miles off the coast. So that distance right there is 3 miles. And we're told that the refinery is 4 kilometers down the coast. So let's say that here is the refinery. And we know it is 4 miles away from that point where the oil well is perpendicular to the coast. And we're told this: laying pipe in the ocean is twice as expensive as it is on land. What path should the pipe follow in order to minimize the cost? Well, this is a very, very, very similar setup to that last problem. The idea is the cost on land versus the cost in the ocean is different, and we want to figure out where should we let that pipe land in order to minimize that cost. So let's again call that distance down the shore x, and that remaining distance has to be 4 minus x. Because again, we know from that point on the shore on the left to that refinery is 4 miles, so if that bit is x, the whole bit is 4. That last bit has to be 4 minus x, because 4 minus x plus x is 4. Okay. Well, again, we're going to need to do some Pythag to figure out the hypotenuse, which is going to be the square root of 9 plus x squared. Okay. You can get there. Watch the last video if you can't get there. So, what do we have? Well, we have a slightly different scenario than the last time. Last time we were talking about speeds and stuff, but now we're talking about cost. So, if you think about the total cost, it's going to equal the cost. How do I want to say this? It's going to equal the, let's say, cost. There's like a cat meowing outside. It's going to equal the cost per mile times the miles. Let's do cost per mile on land times the miles on land plus the cost per mile on water. In water? I don't know. Times the miles on water. In water. Whatever. I can't write, but hopefully you got that. So, how does this work? Because we don't know the cost. But it actually doesn't matter that we don't know the cost, because we know that if cost, let's say this variable cost is the cost on land, we know that the cost on water is 2 times the cost on land. So we're going to have a coefficient of 2 out in front. So our total cost will equal the miles on land, which is what? Miles on land is just 4 minus x plus 2 times the miles on water, which is the square root of 9 plus x squared. It's kind of weird because we don't have specific costs to work with, but it doesn't matter because the relationship is the same. This is going to be our cost on land. This is the cost on land times 2 because it's twice as expensive to do the bit on water. And we have that coefficient of 2. So we are accounting for that. So let's go ahead and figure out a good window. X min, again, let's just go 0. X max is 4, because that would be showing us that we're going straight to the refinery. Y min, 0. It's definitely going to be more than $0. Y max is going to be the distance on water times 2. So it's going to be 2 times the square root of 9 plus x squared if we're going straight there. X is 4, so 9 plus 16. And again, you can just type that into your y equals screen. Doesn't matter. So let's graph this and see what we get. When you graph it, and we're doing cost without units, realistically, and distance for x in miles, we get a thing that looks like that. And we want to find that minimum value. So, second, calculate minimum is option 3. Left bound, hit 0. Right bound, hit 4. Because that's going to say, like, there's my left bound, there's my right bound. There's one minimum in between there, so hit enter for guess, and it will take you to that minimum value where x equals 1.732, and it tells us that y equals 9.196. And we don't really know what 9.196 represents, but we do know that the cost will be minimized when x is 1.732 miles. So, to minimize the cost, land 1.732 miles down the shore from the perpendicular point to the oil well. Imagine if the cost on land was, say, like $20 per mile, which is like crazy low. Then y equals 9.196. Multiply that by 20 would give you the cost. He said vaguely as he ended the video.